Hook. There are languages in the world where the words left and right do not exist. Not because the people who speak them are confused about direction, but because they navigate entirely using cardinal points. North, south, east, west. Always. And here is the staggering part, speakers of these languages always know which direction they are facing, even in pitch darkness, even underground. Meanwhile, most English speakers could not tell you which way is north without pulling out their phone. The language you speak is not just how you communicate. It is how you think. Tease. In the next 10 minutes, you are going to discover something that linguists and cognitive scientists have been arguing about for over a century. We will explore how the specific language you grew up speaking actually changes the structure of your thoughts, your perception of time, your understanding of color, and even how you remember the past. And the most counterintuitive insight, the one that completely upends how most people think about the relationship between language and the mind, is coming up in just a few minutes. Stay with us. Background. The idea that language shapes thought is not new. It has roots going back to the early 20th century, when linguist Benjamin Lee Whorf and his mentor Edward Sapir proposed what became known as the Sapir-Whorf hypothesis. The strong version of this theory, called linguistic determinism, argued that language completely controls thought, that you literally cannot think about something your language has no words for. This extreme position was largely dismissed by the scientific community, and for decades the whole field was treated with skepticism. But here is what nobody talks about: the weak version of this theory, called linguistic relativity, has quietly accumulated an enormous body of experimental evidence. Researchers are not claiming that language traps you in a mental prison. They are claiming something subtler and arguably more fascinating, that the language you speak nudges your brain to habitually notice certain things, categorize the world in certain ways, and even experience time and space through a particular lens. That is a very different claim. And the data behind it is genuinely remarkable. The modern resurgence of this research is largely credited to Stanford cognitive scientist Lera Boroditsky, whose experiments across dozens of languages have produced results that are difficult to explain away. Her work and the work of researchers like John Lucy and Dan Slobin forms the backbone of what we now understand about language and cognition. Main content. Let us start with color, because it is one of the most concrete and testable examples. The human eye can distinguish millions of shades of color. But every language carves up the color spectrum differently. Russian, for example, has no single word for blue. Instead, it has two mandatory, distinct words, голубой for light blue and синий for dark blue. These are not shades, they are separate categories, the same way English treats green and blue as categorically different. When researchers ran experiments showing Russian speakers colored chips and asking them to identify matches, Russian speakers were significantly faster at distinguishing light blue from dark blue than English speakers were. Not because their eyes are different. Because their language had trained their brains to treat that distinction as categorically important. The boundary existed in perception because it existed first in language. Now consider the Piraha people of the Amazon, studied extensively by linguist Daniel Everett. The Piraha language has no words for specific numbers beyond 1, 2, and many. When Piraha speakers were shown a row of objects and asked to create a matching row, they performed accurately with small numbers but became increasingly imprecise as numbers grew. The absence of precise numerical language appeared to limit precise numerical thought in practical tasks. But here's what nobody talks about when it comes to time. Different languages structure time in radically different ways, and those structures bleed directly into how speakers mentally represent temporal sequences. English speakers overwhelmingly think of time as a horizontal line running from left to right. If you ask an English speaker to arrange pictures of someone aging from young to old, they will almost always place them left to right without hesitation. Mandarin speakers frequently conceptualize time vertically, with earlier events above and later events below, reflecting the vertical metaphors embedded in the language. Hebrew speakers, whose language reads right to left, arrange time from right to left. And the Aymara people of the Andes, this one is extraordinary, conceptualize the past as being in front of them and the future behind them. Their reasoning is logical: you can see what is in front of you, just as you can see what has already happened. The future is unseen, so it is behind. The language encodes this, and speakers gesture accordingly. Mid-roll break. Deep dive. Now let us go deeper, because this is where it gets genuinely mind-bending. One of Boroditsky's most striking experiments involved grammatical gender. Many languages assign a gender to every noun, not biological gender, but grammatical gender. In Spanish, the word for bridge, puente, is masculine. In German, the word for bridge, Brücke, is feminine. When Spanish speakers were asked to describe a bridge using adjectives, they tended to use words like strong, towering, and sturdy. When German speakers described a bridge, they tended toward beautiful, elegant, and slender. Same object. Completely different mental associations. And neither group was aware their grammar was doing this to them. This is the subtle genius of linguistic relativity. It does not announce itself. It operates beneath conscious awareness, quietly shaping what you notice, what associations you form, and how you reason about the world. The language is running in the background like software on a computer, and most of us never think to check what program is running. Consider how language affects memory and agency. English is highly agent-focused. We say John broke the vase even when the breaking was completely accidental. Spanish and Japanese speakers, by contrast, often use constructions closer to the vase broke itself when an event was unintentional. Boroditsky ran a study where English speakers and Spanish speakers watched videos of people accidentally popping balloons, breaking eggs, and spilling drinks. Later, when asked to remember who was responsible, English speakers more reliably remembered the agent, the person who did it, even when it was an accident. Spanish speakers were better at distinguishing between intentional and accidental events in memory. The language literally shaped what they encoded and retained. This has profound real-world implications for things like eyewitness testimony, legal accountability, and even how cultures assign blame. Analysis. So what does all of this mean for us, practically speaking? First, it means that learning a new language is not simply acquiring a communication tool. It is literally expanding your cognitive repertoire. Bilingual and multilingual individuals show measurable differences in how they solve problems, how they perceive time, and how they categorize objects. The brain that speaks two languages is, in a meaningful sense, operating with two different cognitive frameworks and can switch between them depending on which language is active. Second, it forces us to question the assumption that our own way of thinking is neutral or universal. Every monolingual person is, in some sense, trapped in a perceptual accent, a set of habitual cognitive tendencies shaped by the language they grew up with. The things we find obvious, the categories we take for granted, the way we instinctively divide up time and space, all of it has been quietly sculpted by language. Third, this research has serious implications for how we build technology, write laws, design educational systems, and communicate across cultures. When negotiators from two different language backgrounds sit across a table, they may literally be perceiving the situation differently. When a legal system built in English tries to apply concepts of intent and agency to communities whose languages encode those concepts differently, something important is lost. Conclusion. The relationship between language and thought is not a simple one-way street. Thought shapes language too, and both are shaped by culture, environment, and experience. But the evidence is now overwhelming that the specific language you speak leaves a measurable fingerprint on your cognition. It changes what colors you see as distinct, how you navigate physical space, how you remember past events, how you assign blame, and how you visualize time itself. The Sapir-Whorf hypothesis was never fully wrong. It just needed a century of careful science to reveal what was actually true, not that language imprisons thought, but that it quietly, constantly, invisibly tilts it. The words you have access to are the grooves your thinking tends to run in. And knowing that gives you something powerful, the awareness to question those grooves, and perhaps, the motivation to learn a new language and discover an entirely different way of experiencing the world you thought you already knew. CTA. Before you go, if you learned something new today, hit that like button right now. It genuinely helps this channel grow. Subscribe to Brain Boost Academy for a new video every single day. We will see you in the next one.